So we're going to look at integration by substitution today. We'll work through one or two problems from the textbook. So this work problem, for example here, is directly from the textbook, page 464. So if you want to have that handy, you don't need to write down this method as we're going through it because they've gone through it anyway in the textbook. So you can just sort of watch what's going on really, and I'll go through the idea. I'll do 2 or 3 examples. The last example we'll look at will be one where we can actually find a value because it will be a definite integral, and then we could try using one of our numerical methods that we looked at to find the area under a curve and see if we can get the same answer, because that's the sort of thing that's going to come up in the exam. You'll be asked to find the area under a curve using a numerical method and then try integrating it using a technique. And there are a few different techniques we'll be looking at, and the first one is this integration by substitution. So, this example then, if you look at the standard integral that's going to be useful here, the standard integral that we want to try and use is this. The integral of ax to the n is ax to the n plus 1 over n plus 1 plus c. In other words, you just add 1 to the power and divide by the new power. The trouble is that this is not x, it's 2x minus 5. And so it does look like the standard integral. So what we do is we make a substitution. We let u equal the bracket. So then we've got u to the 7, and we can integrate that. U to the 7 will become u to the 8 divided by 8. The trouble is, I'm integrating with respect to dx. I need to be integrating with respect to du if I'm going to change it to u. I can't just say to myself, okay, I'm going to call that u, so that's u to the 7, and I'm going to integrate it, because that's u to the 7 with respect to x, and so it's a different variable. So I need to do something about that. So this is the technique. The technique is to let something equal u so that it looks like a standard integral, i.e. this one, and then we can do it. So what we do is we let u equal, in this case, the bit in the bracket, 2x minus 5. And then we differentiate it. Differentiating 2x minus 5, the constant 5 disappears, the x disappears, leaving us just 2. And then we think of this left-hand side here, the du by dx, as a sort of a little algebraic thing, du divided by dx. And so what we do is we multiply both sides by dx, so du equals 2 dx, and then we divide both sides by 2 to get dx equals du over 2. And the reason why we do this little thing is we've now got dx in terms of du. So in the original integral we can replace dx with du over 2. So in this original integral here, dx is going to become du over 2. And then we can change 2x minus 5 to u, and we can do it because now we're integrating with respect to u. So, what do we get? Integral of 2x minus 5 to the power 7 with respect to x becomes the integral of u to the 7 times du over 2. So I've replaced 2x minus 5 with u, and I've replaced dx with du over 2. Okay? I'm sort of getting in the way of it because I'm 3. Can you see? So we've made a substitution. If you think about differentiation, that's the sort of thing we did in there. We let something equal u in the chain rule, or the function of the function rule. Now we do a similar sort of thing. We let part of the inner part of this function effectively equal u, but we can do that so long as we do something about this dx. How do we do something about the dx? We differentiate it we differentiate whatever we've called u so that we can then find out what dx is in terms of du. Now we can do it. That's the integral. It's the standard integral. We just add 1 to the power, divide by the new power. So it equals the u to the 8 over 8 plus c over 2, don't forget. So it's a half because we've got that 2 underneath here. So this 2 goes underneath, so a half of u to the 8 over 8, and so 2/8 is 16, so we end up with u to the 8 over 16 plus c. And then the final thing is to replace u with what we said it was, which is 2x minus 5. So the integral of 2x minus 5 to the power 7 with respect to x is 2x minus 5 to the power 8 over 16 plus c. With practice, there's a shortcut to this. What I'm going to call u is this bit, and I know that what I'm going to do is ignore effectively what's inside the bracket. And if you remember back to when we were looking at the chain rule, that's what we did. We sort of ignored what's inside the bracket, what we're going to call u, and we're just going to integrate this bracket effectively to the power 7. So what's the answer? It's the bracket to the power 8 over 8, which is what we had further up. So that's the integral. But then I have to remember to divide by the differential of this bracket. So with practice I would be able to do this almost in one step. I'd say, okay, I'm going to ignore what's inside here and just integrate it. So get u to the 8 over 8, but if I differentiate this I get 2. So that means I'm going to divide by 2 as well, so the 2 times 8 gives me the 16. But that only comes with practice when you've done a few of them. So you can almost go straight from there to there once you know what you're doing with these things. Let's have a look at another example. So I'll stop this video here and then we'll look at a second example. Okay.